Welcome to Palsa Lab, your destination for amazing discoveries in science, space, AI, and technology. Today, we are embarking on a fascinating journey to the very beginning. How did life start, and where are we headed? It's a journey that starts right now. Let's dive in.
Have we been measuring the entire universe from inside a giant cosmic hole? Right now, we're cruising through a massive mystery, and strangely, hardly anyone talks about it. If it's real, everything we think we know about the universe's expansion could be subtly, but seriously, wrong. The cosmic web, forget the old picture of stars, plus sprinkled evenly through space. Zoom out far enough and the universe looks less like wallpaper and more like a glowing web. Filaments of galaxies strung between enormous dark voids. Most of the galaxies and stars we actually see live in the bright, dense filaments of that web. The empty regions between them are the cosmic voids, which take up nearly 90% of the universe's volume. And according to a provocative hypothesis, we might be living inside one of those voids. The KBC void, also known as the local hole. Estimates suggest this void could be 2 billion light-years across. That's not a small pothole. It's a proper cosmic desert, a region where matter is noticeably less dense than the cosmic average. The Hubble tension. This isn't just interesting trivia. It matters because where we live changes how we measure the rest of the universe. Specifically, it affects the number that keeps cosmologists up at night. The Hubble constant. The speed at which the universe is expanding. To measure this, scientists use two independent rulers. The first ruler looks at the very early universe, the cosmic microwave background, or the afterglow of the Big Bang. That gives us a value near 67 kilometers per second per megaparsec. The second ruler looks much closer to home, using standard candles, like supernovae and Cepheid stars. That method gives a different number, about 73. Put plainly, 67 versus 73. That 9% gap is what we call the Hubble tension. It's one of the biggest puzzles in modern physics, and it suggests either our math is wrong, or we are missing a huge piece of the puzzle. How the void fixes it. This is where the KBC void comes in. Imagine a giant transparent bubble whose walls are dense with galaxies and dark matter, while the interior is nearly empty. Metaphor 1. The ship. Think of our galaxy like a ship floating on a slow-moving current. Even if the ship isn't running its engines, the current carries it along. Because gravity always pulls toward mass, the dense walls of the void exert a stronger pull than the empty center. This creates a local flow. As we look at neighboring galaxies, part of the speed we see might just be this local motion as everything drifts toward the walls. If we don't account for this current, our local measurements of the expansion rate will look higher than they actually are. Living in a void doesn't just mean we are lonely. It means our perspective is biased. The physics of voids. Why do galaxies move this way? There are no gravitational centers in space. Instead, gravity works through density differences. Metaphor 2. The marble. You can imagine this like a gentle slope. A marble placed on a tilted surface doesn't need to be pushed. It naturally rolls toward the lower side. On a cosmic scale, that slope is created by gravity. Galaxies aren't being pushed away from the center of a void, they're gradually rolling toward the massive structure surrounding it. Over time, these voids grow. Not because dark energy is stronger there, but because there's less gravity to slow the expansion down. Voids expand more freely than the rest of the universe. Cosmic weather and life. This difference in local dynamics makes voids quieter environments. In dense, galactic cities, galaxies collide and black holes flare up constantly. Metaphor 3. The suburbs. In our large underdensity, the cosmic weather is calmer. It's like living in a quiet cul-de-sac instead of a chaotic downtown intersection. While life on Earth depends on our sun and geology, it's a poetic thought. Perhaps the cosmic suburbs provided the long-term stability needed for life to thrive undisturbed for billions of years. The dark implication, but there is a darker side to this. The universe is gradually hiding its past. Because the expansion of the universe is accelerating, most galaxies will eventually recede beyond our horizon, moving away faster than the speed of light relative to us. In a few 100 billion years, the Milky Way and Andromeda will have merged into one giant galaxy. Future astronomers in that era will point their telescopes at the sky and see nothing. No other galaxies. No afterglow of the Big Bang. Using flawless instruments, they would conclude the universe is small, static, and that their galaxy is the only thing that has ever existed. They would be perfectly logical, and they would be completely wrong. Reality will have erased the evidence. Conclusion: that thought is humbling. Our measurements are powerful, but they are made from one tiny vantage point inside a vast and structured web. The KBC void is still a live investigation. It might be the answer to the Hubble tension, or it might just be one piece of a much larger mystery. But it reminds us that every observation comes with a point of view. Summary: we might be living in a huge local underdensity that skews our view of the cosmos. The idea is plausible, physical, and currently being tested by the next generation of telescopes. Memorable takeaway: sometimes the biggest mystery isn't what's out there, it's the perspective from which we're looking. If you found this deep dive into the cosmic web interesting, like the video and subscribe to Pulsar Lab. Share this with someone who needs a reminder of how small, and how unique, our place in the universe really is. Thanks for watching, and we'll see you in the next one.